Examples of norms and angles between vectors in Euclidean 4 space. Here is a problem. Let x equals to a tuple of 3, -1, -1, 1, and y equals to a tuple -2, 2, 1, and 0. Compute the norms of x and y and the angle between them. Since right here we didn't state explicitly about what is the underlying structure, so we'll assume that it is a Euclidean space, and here you have 4 elements in x and 4 elements in y. That's why we'll assume that it is a Euclidean 4 space, which means it's a 4-dimensional Euclidean space. Normally, without further notation, we'll already equip the Euclidean space with dot products, addition, norms, and some of the common operations between vectors in Euclidean space. So first of all, we'll deal with norms. We define the norm in a Euclidean n space Rn as, it looks like absolute value, v, which is the vector in Euclidean space, equals to square root of v1 square plus v2 square plus up to vn square equals to square root of v dot product v, where the norm v must be non-negative. The reason why it's non-negative because in some metric space or in some other spaces it can be negative, but then because we're dealing with the Euclidean n space, that's why it's positive traditionally speaking. And v is an n-tuple of real numbers r. So with that definition of norms, now consider x equals to 3, -1, -1, 1, which is an element of R4. Then norm x equals to square root of x1 square plus x2 square plus x3 square plus x4 square. We can then substitute all of the numbers, which is the first element, the second element, the third element, and the fourth element of x into the x1, x2, x3, x4. It equals to square root 3 square plus -1 bracket square plus -1 bracket square plus 1 square. And so it equals to square root of 9 plus 1 plus 1 plus 1, which is square root 12. And so that the answer is 2 square root 3. Similarly, we consider y equals to -2, 2, 1, 0, which is an element of R4. Then norm y will equals to square root y1 square plus y2 square plus y3 square plus y4 square, which is equals to square root -2 bracket square plus 2 square plus 1 square plus 0 square, which is equals to square root 4 plus 1 plus 0, which is equals to square root 9. But since we already talked about that the norm must be a non-negative one, so this one will discard the -3 and the only answer is 3. In terms of the angle between x and y, we recall two different definitions of dot product. The first one is if you have x dot y, which both of them they are in the Euclidean space, it will equals to the summation of from I equals to 1 to n xi times yi, which means you just take the first element of x and the first element of y, you multiply them together, plus the second element of x and second element of y, you multiply them together, plus so on and so forth until the nth element of x and the nth element of y, you multiply them together and you add all of these products together. That's the dot product between x and y. There's another definition because in Euclidean space, we are already very familiar with angles. So how we define the dot product is you have norm of x times the norm of y times cosine theta, which the theta represents the angle between these two vectors. With these two definitions and with the information that problem gave us, then we can try to calculate the angle between these two vectors. So we have the first definition on the left-hand side and the second definition on the right-hand side. Then we can plug in the numbers. We take the first element of x and the first element of y, which is 3 and -2, and then the second element of x and second element of y, which is -1 and 2, so on and so forth. Then we put all of the numbers on the left-hand side. On the right hand side, because we already calculate the norm of x and the norm of y, so we can also plug that in, which the norm of x equals to 2 square root 3 and the norm of y equals to 3. Now I've flipped the left hand side and right hand side and then simplified a little bit, so it becomes 6 square root 3 cosine theta equals to negative 6 minus 2 minus 1 plus 0. Then we move the 6 square root 3 to the right hand side, so it becomes negative 9 over 6 square root 3, which we further simplified of some cancellation and also rationalization of the denominator, then it becomes negative square root 3 over 2. And now we can simply apply, we assume that the angle between these two vectors is less than 180 degrees. By applying the function arc cosine or cosine inverse bracket negative square root 3 over 2, then we'll get 5 pi over 6. And so that is the solution.